So when you save a file to the cloud, where does it actually go? We hit save and just trust that it's somewhere. Today, we're going to explore a pretty radical alternative, the decentralized Autonomi network. We're going to see how uploading a file here isn't just a small tweak, it's a complete rethinking of how we store our data. Let's dive in.
And this slide right here just nails the core difference. On the left, you've got the model we all know, a central server that you're basically renting, with a big company holding the keys to your stuff. But on the right, well, that's the Autonomi way. A whole network of peers, a one-time payment, and most importantly, you are the one in control. This shift is the key to, well, everything that comes next.
To make this crystal clear, we're going to follow the journey of a single file. Yeah, just one file. We'll see how it's prepared, how it's stored, and how it's retrieved on a network that works without any central point of control at all. Now, the journey of your file, it starts right on your own device, not on some far-off server. Before it even thinks about going out onto the network, it gets prepared by being broken down, or, shattered, into hundreds of tiny encrypted pieces. The software on your device, what we call the client, handles all this for you automatically. You just pick a file to upload. The client then chops it up into these small uniform pieces, and then it assigns a totally unique digital address to every single one of them.
These little pieces have a name. They're called chunks. And this digital zip code idea is the perfect way to think about it. That address is absolutely crucial because it tells the network exactly where in the vast digital space that specific piece of data belongs.
Okay, so now we've got a swarm of these tiny addressed data chunks. The next big puzzle to solve is how do we find a safe and secure home for every single one of them across this massive network? This is where that digital zip code becomes so incredibly important. See, the client doesn't just shout into the void and hope someone answers. No, it's way smarter than that. It precisely targets only the computers, the nodes, that are responsible for that chunk's specific address range. It makes the whole thing incredibly efficient.
But hang on a second. What if one of those nodes is offline, or, it just doesn't respond? In a normal system, that's an error message, a big red flag. Does that mean your data is in trouble here? Is it just lost?
And this is where the logic of this network just completely flips the script. On Autonomi, silence is not an error. It's actually a valid response. It's the node's way of saying, hey, I can't take this chunk right now, but you should ask my neighbor. So the client just shrugs and moves on to another perfect node in that same address space. No big deal.
Okay, so the client starts getting a bunch of offers from available nodes that say, yep, I can store that chunk. How does it decide which ones actually get the job? Believe me, it's not random. It's a really deliberate and smart selection process.
Think of your client as a super smart agent, working just for you. It's weighing a bunch of factors to get the best deal. It looks at all the storage offers it receives, hunts for the best price, checks that the node has enough space, and, this is key, it makes sure that chunks are spread out all over the network for maximum safety and redundancy. It's all about storing your data securely and economically.
So at this point, all the little chunks of your file are safely scattered and stored across the network. But how on earth do you put them all back together again? The answer is pretty cool. You create a one-of-a-kind key, basically a digital treasure map for your data. While the client is busy sending all those chunks out, it's also playing the role of a map maker. It is meticulously, carefully recording the exact location of every single piece, and it puts all of that information into one single crucial file. And that file is called the data map. Honestly, it is the absolute key to everything. It holds the coordinates for every scattered piece, which lets your client instantly find them and perfectly reassemble your original file whenever you want it.
So we've walked through this really elegant technical process, but what does it all really mean for you as a user? How does this fundamentally change your relationship with your own digital life?
Well, with your data map in hand, you can get to your files from any device, anywhere. You have total freedom to organize your data however you want, whether it's in archives, vaults, or scratchpads. And maybe most importantly, you have complete control over what you share and what stays private. You are in the driver's seat. Let's just pause on this for a moment. This whole process, the shattering of the file, the intelligent distribution, the seamless reassembly, all of it happens without a single central server calling the shots, and without any of those annoying, recurring monthly fees. And that leads to what is probably one of the biggest paradigm shifts in how we think about data storage. You pay once, and your data is stored permanently. It's a huge move away from just renting digital space to truly owning it.
So when you put it all together, by giving control back to the user, getting rid of those single points of failure, and totally upending the economic model, this technology poses a really powerful question. Are we looking at the future of data ownership? It really paints a picture of a future where you don't just rent your digital life, you actually own it.